All right. It is 10 a.m., so we can get started with day two of the weed management portion of crop hour this week. I appreciate everyone jumping on and joining us today. I think honestly, today's presentation, although it's going to be a little bit different than previous presentations and other things, kind of more data oriented. I'm going to suggest that this one will probably be very important and pertinent as we move forward, using herbicides to manage weeds. As some of you may know or already know, the EPA's implementing the Endangered Species Act, and it's going to really change how we apply pesticides. And reluctantly admit, being the state weeds management specialist, it confuses me too. So I think today is going to be a really good presentation. And I'm happy to introduce the speaker today, Dr. Stephen Robinson, who is our university pesticide safety coordinator. Although his background, I would say, is more insect ecology, he's really taken off and running with the pesticide safety coordination and management, and not just centric on the insects, but all pests as well. So, Stephen, I want to thank you for giving this presentation today. I think it's very important, and there's no one better than you to give it. So I'm going to let you take it away.
All right, thank you, Dr. Jones. That was a. I hope I can live up to the introduction. Um, like Eric was saying, this is a new regulation that's coming down the hatch from EPA, and I know there's been a lot of confusion about it. I'm going to detangle some things today. It's actually far simpler than I think a lot of people are starting to think. Now, how we get to a certain stage where we're legally able to make applications, that may take a little bit of work, but I'm here to tell you guys that there is plenty of time to make changes if you find it necessary. There's plenty of time to make changes in order to get yourselves to compliable. And I don't want you to worry about it. I'm going to go through this. I'm going to go through it slowly. It's a sort of a slow present or a short presentation, but it's going to cover everything in sort of a broad sense. And so that I want you guys to look at this as more of what can I do? How do I address this? And how do I approach this in years to come? So I'm going to go ahead and get started here. Okay, so my name is Stephen Robertson. As Eric was saying, I am an entomologist. I am trained to study insects. I focused more on pollination and insect ecology. When I started this role, my understanding of pesticides was as anybody that goes through any kind of broad scale entomology training, it's decent. But when it comes to like herbicides and fungicides, some of those and the way they act and behave, I didn't really know. I've learned a lot since I've been here. Absolutely love the job, and I love working with you guys. So I'm really excited to be able to give this presentation. So just to give some quick background, like I was saying before I started the slideshow, the EPA has introduced a new regulatory approach to using pesticides. Essentially, what it amounts to is we're trying to mitigate drift and runoff. We're trying to keep things on the farm so that we're not affecting off target sites. Pretty simple, pretty basic. And I'm going to give you some of the reasons and the motivations for that. And I hope it connects because this is going to be important. And again, it's like I said earlier, it's actually far easier than you might think. Let's go ahead and get started. Let's look at the objectives here. So first thing, like I said, a big thing about this new mitigation, these new regulatory efforts, is to control pesticide drift. So I want to look at pesticide drift, talk about what it is, how we can sort of demarcate it and recognize what's going on. Then I'm going to give you some historical context for the ESA. That's the Endangered Species Act. Why is that important, and how does that come in to affect the way that we can use pesticides? Then I'll cover the actual strategy itself. I'll go into a little bit of detail about what the approach is, but again, it's sort of I want to give you a broad view, sort of give you that basic look, and the idea again, it's real simple. You'll be able to do it. It's not as big of a deal as people are thinking. Um, give you those motivations for those new regulations. Then we'll look at the scoring system really quickly. I'll show you guys some ways that you can add points. And if we have time afterwards, I'll visit the EPA mitigation menu. I've got links on here. So when we get there, I'll give you guys a second to take some pictures. They're QR codes. Please visit those and check them out. The information there. It's really lining you guys up to be successful in this. And then we'll look at some pesticide drift measures to control it. So what is pesticide drift? Pesticide drift is quite simply the unintentional. So when we want it to move, right, that's a good thing. It's the unintentional pesticides away from where you wanted it to be to a place where you didn't want it to be, and where to a place where it might have a negative or an adverse effect on the environment or some plant species or even any other species other than the ones we're trying to control. And so I want you to kind of think of it as there's two real things going on here. You can split it up into primary drift and secondary drift. And when we're talking about primary drift, we're talking about drift where we've actually made the spray, but it never reaches that target. Something takes it, throws it off target, it goes somewhere else, doesn't even do anything at all. Secondary drift would be it reached it, but then something happened to wash it away. And I want to take a quick look at some primary sources of drift. Big one, especially here in South Dakota, guys, it's wind. And so when you got high wind events, it doesn't matter what sort of droplet size that you're using, that stuff's gone. And if we're not keeping that herbicide on property, it's a huge waste of money. And so we really do need to be focusing on how to control that drift, because the only way that these pesticides work is if they're applied the way that they're supposed to be applied based on the label. And so when we get any kind of wind event that blows it off and we're like, hey, this stuff doesn't even work. Well, that's actually not the case. You might have made a bad application decision on when to do it. And instead of giving a good efficacy for your application, it's gone. It's actually killing your tree rows. The other one that I want you to think about is droplet size. That one's pretty simple, right? So the larger the droplet, the less likely it's going to be moved about by outward forces. And so if we're just looking at the wind, see that big drop doesn't move a whole heck of a lot. Medium drop, it'll go. And then that small drop, if you guys are using like very low or very small droplet sizes, you do get great coverage, but there's a good chance, especially with low wind, that you could just blow it off target. So got to be paying attention to those types of things when we're making applications. Another thing, and hopefully you're all very familiar of it. If any of you don't know what this looks like, if you ever go out in the field and you see this, this is not the time to spray. This is what you call an atmospheric inversion. And just to give you some graphics of what that looks like, on a typical day, that warm air has a current. It moves upward, and that sort of movement allows pesticides to behave the way that they're supposed to. When you get a cold layer that's trapped between a warm area, that air will just rise and then it just sits there. And so it's like that picture I showed you before. It's just like a cloud layer that's just sitting steady. Well, unfortunately, that's never going to come down. What ends up happening is it floats in the air, it stays suspended, and as soon as a new weather front or a new system moves in, it's just going to blow that off somewhere else. So never make applications in an inversion. I also want to look at those secondary sources for pesticide drift. Biggest one is going to be rain. And I'm sure you guys have heard Eric talk, or you've heard and you know about herbicide uses. Some rain, and it depends on what pesticide we're talking about, is actually a good thing, right? And so when you apply that pesticide on the surface, we actually need that pesticide to get down into the roots, particularly herbicides and some insecticides as well, and I'm sure some fungicides. But we want that to get down to the roots so the plant uptakes it. Sometimes it's not absorbed through that epidermal tissue and above surface. So we do need to get it down into the roots. Some rain's really good. A huge rain, it doesn't matter what pesticide you're using, especially those soluble ones, those water soluble ones, they're going to be gone. They're just going to wash away. And so we're talking about, treating a soy plant. If you treat just before rain, good chance that pesticide's just going to get down in the soil, continue to wash down into the water table, or leach off or run off of the top of the soils into the waterways. And that's one of the biggest places we don't want this stuff. It leads to runoff, seeping, and leaching. And irrigation can do this too. And again, make sure you're reading the label, because in some cases, we've been in a drought for quite a while. You do need that irrigation, and you do have to apply that sort of irrigated measure in order for that that pesticide or that AI, that active ingredient, to get out of the soil and be uptaken by the roots. So make sure you read those labels, what's required. But this heavy irrigation, especially after a pesticide application, could be a source for runoff, seeping, leaching, the secondary drift. I want you guys to take a quick look at this. And then I'm going to show you guys some dramatic pictures of what runoff looks like. And hopefully your farm doesn't look anything like this. But you can see when a rain comes in, especially for those extremely water soluble, if you don't have permeable soils, if that water is just going to hit the soil and then stay on the top rather than get down into the roots, all that water is just going to pull all of that active ingredient off, and you can see it'll go straight to those ditches, straight into the waterways. In some cases, I know some of you guys probably have water bodies running through your farms. It's going to go there, and it's going to be carried off into, eventually probably into the Missouri. So we want to avoid that type of pollution. And again, it's economically sensible. We don't want that product in the Missouri. We want it on our farm doing the work that it's supposed to be doing. And that's one of the important things about watching the weather. And here are some pictures, some dramatic pictures, mind you, of what runoff looks like. This poor person, definitely not, either it's a super heavy rain event, which is highly likely, and a combination of poor soil permeability. Any application that this person has made in the last probably week that had not been completely absorbed might be running off in that water. Something to keep an eye out. And this is also another thing that leads to it. And of course, what we're seeing here too is that topsoil, that all important topsoil is being washed away too. And that topsoil is probably contaminated with fertilizer as well as pesticides. So not only do we not want it because that topsoil is valuable, but it's also harboring our chemicals. So we want to watch those weather events, make sure we're not doing things that might put us at risk of primary or secondary runoff. And this is what it looks like. So this is a case of eutrophication in an ag adjacent water body. What happens is this nitrogen gets down, sort of causes an algal bloom, which releases some nutrients down in the soil of that waterway, which only encourages the deoxygenation and then the algal bloom. So you get this really, really foul looking water. Definitely not one that you or anybody else would probably want to swim in. By the way, I have swam in an algal bloom before, and you come out just covered in green. It's not going to hurt you, but it is kind of weird. um, yeah. And so let's take a quick look at the pesticide mitigation strategies. Again, this is a new approach to protecting endangered species. That's the big thing here. We got to protect those endangered species and their habitats from pesticide exposure. So we'll just take a quick historical context here. First of all, FIFRA, or the Federal Insecticide, Fungicide, and Rodenticide Act, was passed in 1947. This was really designed to add to and sort of take care of some of the faults of a previous act called the Federal Insecticide Act that was established in 1907. Really, all that did was protect consumers. There were a lot of people coming out like, oh, you got bed bugs? Throw this powder on there. And people were paying for it and they weren't getting any effect. In fact, they could potentially be hurting themselves. So the government stepped in and said, hey, we got to protect consumers. But post World War II, we see the rise of a lot of synthetic compounds used for pesticidal properties. Just like one in particular is DDT. You guys know the story behind DDT, I hope. And so overuse led to a lot of problems in the environment. And so in 1947, the government has to step in again and say, hey, we got to do something about this. How are we going to regulate this so we're not just like killing our land, ruining our natural resources? FIFRA, 1947. The EPA, the Environmental Protection Agency, was created in 1970 by Richard Nixon. And it sailed through Congress. And so it was one of those things that they were like, yes, this is something that we absolutely need. And it wasn't until 1972 that they were tied to FIFRA. It was the FEPCA, or the Federal Environmental Pesticide Act, that gave FIFRA the responsibility to protect the environment for endangered species and public health. And then the endangered species was passed in 1973 to protect those endangered species. And so we've got this line of regulation that's basically leading to, okay, the EPA now has the authority and the responsibility. Now that's a big one, the responsibility to protect the environment and public health and endangered species. Let's look at the regulatory context here. What is an endangered species? Well, there's five criteria for listing species. I'm not going to spend too much time on this. The present of threat, destruction, modification, or curtailment of its habitat or range. This is pretty common. Overutilization for commercial, recreational, scientific, or educational purpose. This is not necessarily as common, but it does happen. Disease or predation. This is natural. We have no control over this. We can't do anything about this. Maybe go out and shoot some predators or try to release something that might protect them from diseases. But not much we can do about that one. The inadequacy of existing regulatory mechanisms. Boom. That's really important. Okay. So again, the EPA is responsible for pesticide usage that might affect the ESA, the Endangered Species Act. So inadequacy of existing regulatory measures, other natural or man-made factors affecting its survival. Pesticides fall in there. Most of those are synthetic. They're going to be man-made. Some of the organic ones are still going to have been processed and are still considered man-made. So what happened is the EPA has had to, rather than take a reactive approach when something comes back and it says, oh, hey, this isn't working. Okay, well, let's change something. They're trying to take a step beforehand and make it a proactive approach to reduce that pesticide contamination and offsite targets and offsite exposures. And so it's important to understand the motivations of why they're doing this. And I think you guys need to understand this in order to comply in a way that you're going to be, I'm not going to say excited about it, but at least you'll recognize the importance of it. And so really it comes down to a result of unsatisfactory regulation. We just didn't have the right measures in place to really control some things. And part of it is inadequate testing or modeling. And what that amounts to is we don't have 40 years of data to show that, a pesticide could have an effect if it's there chronically or persistently for a long period of time. We just don't have the right models maybe to represent that. This model itself, this is like one of the best models I've ever seen. Doesn't look like that. And by the way, this is happiness. So to money. So if you ever thought money doesn't buy happiness, according to this graph, and I'm not sure if I didn't look, I don't know if the research is legit, but according to this, you do have a higher chance of being happier if you're wealthy. I can't speak to that. I've never had that kind of money. Continued species declines has been a serious problem. Now, a lot of that doesn't necessarily have anything to do with agriculture. A lot of that is climate change and the way that things are pushing habitats that used to be good for a species. It's no longer, and so they're having to figure out ways to deal with that, and some species just can't. So continued species declines. Of course, we know the monarch, the black-footed ferret, the piping plover, and then one of my favorites, the sandhill crane. It does fly through here. So, and these are things to pay attention to, and hopefully you guys are aware of how to mitigate those measures. We might look, if we have time, at Bulletins Live 2 to show you some restricted use areas. And then another problem is non-compliance. And so those labels are there not just to highlight how this works, why it works, and when it works, but it's also to guide you into doing the right thing in order to avoid it getting off site. And that's why we have inspectors. That's why we have a licensing program. So if you guys do something wrong, the label's there, it lays it out. If you don't follow that label, you can find yourself in trouble. And that's one of the reasons that it leads to some of these overarching regulations, because people aren't doing what they're supposed to. EPA steps in and says, well, I got to tighten that grip. And so what has happened because of these things? Just excessive litigation. EPA is getting sued for not protecting. They are getting sued for over-regulating, stepping in places and saying that applicators need to do certain things that they don't have the authority to say. And so they're getting sued from both sides of things. And so how do you balance? Importantly, I want to say that when EPA gets sued and when they pay that money out, it comes out of tax dollars. I was shocked to find this, but we are actually funding all the mistakes that we're making and causing the EPA to get sued for because they're not doing their job. We're paying for it. That's a big deal. I want that to settle in. We don't want the EPA to get sued. We don't want to sue the EPA because that's tax dollars that could go everywhere else. And I'll say this too, the payouts, the amount of money that's going into this, it's outrageous. It could easily fund so many other things. So let's not have that go on. And so the EPA had to ask itself, like, how do we balance our responsibility with protecting things without overstepping our bounds? And that's tough. So what they came up with, and this is just a quick look, is the EPA pesticide mitigation strategies based on the Endangered Species Act. And it's real simple. It's like I said before, it's actually a lot easier than you might think. So what we're actually looking at is just a point system based on drift. And in order to understand drift, we've got to look at pesticide, right? We've got to look at the pesticide itself. What characteristics of that pesticide might lend it to drifting off target? Well, there's volatility, there's going to be solubility, and there's toxicity as well. And so volatility really just amounts to it. And if you guys have ever used dicamba, you're probably familiar with recent regulations that have sort of pushed that out. Um, and it's because it's extremely volatile. Once it sits down or once it gets down onto it, it doesn't stay there. A lot of times it can pop up and then drift off site. And so volatility is really important to recognize. How long should it stay out there? What's the sort of delta T? That's the evaporative potential in the environment at the time. What's the likelihood that it's going to get back in the atmosphere and blow away? Solubility, of course, is how well it dissolves. Particularly what we're talking about is in water. So those highly soluble things, it'll just get picked up by rain and pulled straight through the soil because nothing can hold on to it but that water. And of course, toxicity is important. The more toxic something is, the more we really need to pay attention to it. And so it's also important to recognize, and so we use this to give a rating, a numerical rating, a pesticide rating. This would say just a 9. I'll say that a 9 is going to be a very high score. It's unlikely that there's probably products out there that you're going to use that are going to be at a 9, but that's a very high pesticide rating. But I want to show you guys how to get to a point score of 9. And so really what it amounts to is that we got a pesticide rating, and then we've got location points. So how are we allowed to use that product? Well, we have to have a farm rating above that score of 9. And so there's a point scale, point system that allows you to build points based on those mitigation strategies that you've employed on your farm. And like I said, I'll cover those in just a second. Points for just the location itself. We're talking about soil type. How permeable is the soil? Are we talking sand and is water just racing through just to get to that water table and drift off site? Or are we talking about something a little denser that's going to hold on to that pesticide? What's the sort of precipitation? Like I said, it's one of the biggest sources of secondary drift. And so if if we're in an area of heavy rainfall, strong chance that keeping things on site is going to be a little bit difficult, a little bit harder. Proximity to water is going to be very important as well. How fast or how much of a time period, how great of a distance do you have between where the pesticide is and where it gets into our water bodies? And then, of course, proximity to endangered species. Like I said, if I have time, I'll go through some pesticide use limitation areas. Really covers endangered species, and it says where you can and cannot use, and if you can use, very specific conditions on which you have to use it, like a buffer zone, 120 feet or more. And in most cases, for location in South Dakota, you're going to just get a flat rate of 2. Based on these things, you're going to get a 2. And I have a map on here somewhere. First, yeah. So first thing I want you guys to do is pull out your phones, take a second, take a picture of this. I'm going to leave it here for just a couple seconds. This is the EPA's mitigation menu, and what this does is it provides you a list of mitigation approaches that will give you points in order to be able to meet that pesticide rating and then be able to use that chemical on your property. So I'll leave this up for a second. All right, I'm gonna switch over here. There's another QR code, so keep your phones out. And so this is the EPA mitigation measure descriptions. Everything that's described in that previous website, it says you could do this, you could do this, this is how it controls. When you go into these measure descriptions, it tells you what exactly it's talking about, and it tells you what exactly those measures could be and why they add to reducing runoff or drift. I'll leave this up for just another second. Okay. So when we look at the map of the United States, they've gone county by county and sort of characterized the soil type, precipitation, and they've established a point score. Um, and you can see here in South Dakota, I'm going to take this away. I tried to zoom in and give you guys a close look. Man, this is a terrible picture. When you zoom in, it gets really blurry and awkward looking. But you can see here, Pennington County over here, that one's going to be in the tan. And so light blue, most of the state, going to be 2 relief points or 2 points for your location. Those yellow or tan spots, that's going to be 3 relief points or 3 points to your overall score. And so what I've started with is that 2, which is where most of South Dakota is going to sit. So let's take a closer look here. Also, pay attention to this bottom part of this slide. It's on every slide from previous ones and throughout most of the rest of the this is going to take a long time. Some people are suggesting 15 years. For you guys, I think the changes that you're going to need to make, if any, some of you guys are already there. You're probably already at a place where you can use most of the chemical. It's not going to be a heck of a lot of changes, and there are easy ways to make points. I'm gonna cover some of those easy points, and I'll cover how you can achieve the scores that you need. But it's going to take years. The big issue I think that we're running into is how are we going to regulate this? You know, how does an inspector come out and ensure that you've got proper drainage, that you've got drain tiles, that you've got a water retention system? You know, they got to look at a lot of records. It's a regulational nightmare. So for anybody that's involved in inspections, I don't envy them. But again, 15 years to sort of figure out. So what are some, and this is not an exhaustive list. Go to that website, check it out. It'll give you the exhaustive list. Um, some drift runoff mitigation strategies, conservation tillage, contour farming. That's not something that people are probably going to practice here. It depends, you know, if you've got a terrace system, something that you could use. If you've got sort of an incline on your farm that you could potentially do that, might be something to consider. That's a decent amount of effort. Cover crops, not too bad. A lot of people are already doing it. Guess what? You get points for that. Water management. We're in drought. I'm sure all of you guys are watching your water very closely. If you do irrigate, you're probably metering it in such a way that you know just exactly how much is going out there and you're controlling it. Water management is important when we're talking about drift and runoff. And so if you're doing some of these things, you could take a 2 to a 6, like 6 really, really fast. And this is just for the cropped area. And so what about other areas? You know, because we're talking about drift, we're talking about it getting from cropped area off. Well, it's not just the cropped area that we manage, we own adjacent areas as well. So in some of those adjacent areas, we could do vegetative filter strips. That would be like cut off a row, and instead of doing like a soybean planting, just plant something like alfalfa. If you've got a water body, maybe for 20 feet outside of that, plant some alfalfa. You can hay it later as long as it's there, as long as it's a vegetative filter strip for the time being while you're growing those crops and you're applying those pesticides. You should get points for it. Hedgerows, that's something that's not terribly uncommon. If you got tree lines, that counts as well. So make sure that, you know, again, a lot of these things already exist, so make sure that you recognize that there are actually easy ways to get points. Filtering devices, water retention systems, some of these are much more involved. Water retention system, it depends on how you approach it, but there are some, you know, just a berm could do it. In some cases it's a lot more expensive and involved. But those are things that you can do in adjacent areas and easily take it from in this example, a 6 to an 8. All right, so now, and again, remember, pesticide rating of 9 is extremely high, but heck, we're really close. 15 years to implement, you've got time, but there's still more points that we can use. And so what about our application practices? Surely there's some measures that we could take, some changes that we could make in how we approach this. We just reduce the risk of runoff or drift. Like I was talking about earlier, larger droplet size. Why not? The larger the droplet size, the less likely wind's going to blow it offside. Wind conditions, watch those wind conditions. If it's coming out of the northeast, make sure you give yourself a strong buffer on the southwest part of the farm. That way, rather than, you know, if you've got a 10 mile an hour wind, chance for drift is pretty good. We're still on label, but we've given ourselves a larger buffer range. Maybe you're not going to get the exact treatment in that southwest portion of the farm, but again, the wind's carrying it. So as long as we recognize the wind conditions, we give ourselves an increased buffer over there, and we document that, we actually have records for it, we're going to get points for it. So make sure you're monitoring those wind conditions. Get yourself up to 11 really fast. Now we're perfectly fine with applying a pesticide rated at 9. But there's more that we can do, so we can take it even further. Buffer strips, lower rates, rather than going out and applying the full amount of pesticide or the full rate of pesticide. Keep your records. If there's a plant or a weed in your field that is susceptible to a certain pesticide, use that pesticide at a lower rate. Or heck, why not even do targeted applications rather than doing a sweeping broad sweep over your entire crop field? If you could get out there and do spot sprays, it's not realistic for a 10,000 acre operation, but if you could get out there and do spot sprays to take care and get control of your weed problem, heck, that's definitely going to give you guys some points. So focus on ways that we can reduce the amount of pesticide that we're using, and that we're doing it in the ways that are known to be good mitigation controls for runoff and for drift. Fewer applications. So I know a lot of you guys, you might go out there and you see a bug and you're like, time to spray. If we employ some scouting, not only are we saving ourselves a lot of money by not doing unnecessary applications, when we go out there and scout, we know exactly when we need to apply when we're going to start losing yield. If you go out and spray when you find one insect, that one insect is probably not going to have any effect on that yield. And so you've wasted a lot of money. You've reduced your overall net profit just because you made an application that was not necessary. So fewer applications. How can we get to fewer applications? Scouting is a good way to do it. And now we've gone up to some a rating of 15, and I don't know that there's going to be a pesticide that's rated above 9 or 10. We'll see how things happen, but 15 is pretty dang good. And some of these are pretty obvious, but how do we get some others? Again, 15 years, plenty of time. There's some easy points, really simple. Like I said, and I advocate for this record keeping. Not only does it help you make informed decisions going forward, but if you're tracking those measures, the EPA wants to recognize that and reward you for it. So you can get points for just getting out and being grumpy with a computer and taking some data over your grain. And having a nice farm book there. It doesn't matter if you keep it digitally. You can even have a cell phone app. I know there are apps out there that help you take some farm data. There are also some really nice programs out there. Hopefully you guys have access to those. You could write these things down too. And so EPA doesn't say it has to be digital. It just has to be taken. So track those mitigation measures. What are you doing? Record them. EPA is going to reward you for that with some points. Get some technical, ask a specialist, ask an expert, get some direction, call extension, write it down. I talked to Dr. Jones about what pesticide to use at what rate in order to achieve this result. This is what he told. There you go. You've worked with a technical specialist or an expert, and you've potentially gotten yourself some more points in order to be able to apply these pesticides. Conservation programs. If you guys are working with a CRP or some of those wetlands conservation programs, you get points for those. And so there's some that you can do with just a small change. Reduce your annual pesticide input. Like I said, per application, target it, make it exactly the amount that you need to use to get the effect that you're looking for, and that might be lower than the highest rate that's prescribed, and that's valuable because then we're potentially reducing that risk, reducing the amount that could run off. So reduce that input. Fewer applications, lower rates. Reduce how much of the field you treat. Like I said, rather than going out and treating the whole field, if you've got an insect problem, a potential way to control those things, do a banding application. Go out and every fifth row, do 5 rows. And so you've got a 5 rows on, 3 rows off, 5 rows on. And then what you end up having is extremely good control, but you've reduced the amount of active ingredient that you've had by 3/5 or 2/5. So pretty good. Precision applications, like I said, if you wanted to get out there, if it's reasonable and feasible for your operation, get out and do spot sprays. Get out and take your tractor out to that part of the field that's just got a bunch of weeds and just target that part of the field. As long as you're getting it before it's seeded, as long as you're getting it before that seed has spread, you could potentially knock out that problem, which is a very focused spray. So precision applications are going to be important. And going forward, when we're talking about precision ag and precision applications, it's going to be a big thing. And I hope you guys are starting to take that approach towards this. It could save you a lot of money. It is more involved, but it'd save you a lot of money. Incorporate things into the soil. And so, if you've got irrigation system, again, sometimes we want that product to get down into the soil. When it sits on the surface, remember, we get that heavy rain event, that runoff, it's just going to carry it away. We need to get it down. There's a very certain amount of water that we need for that. It's going to be on the label. It'll tell you irrigate with a 1/4 inch, irrigate with a 1/2 inch after applying within 24 hours. Or it'll say something like, don't apply within 48 hours of a rain event. Sometimes that's difficult. Weather is not always the most friendly, right? But then we can incorporate it mechanically as well. And so we go out and we disc it afterwards. We do some sort of integration of that soil. That way it's not sitting on the surface and potentially going to run off. There's several conservation tillage approaches that you could take that would really help. A big one is no tillage. And the reason that that's helpful is because we're keeping our root systems intact underneath the soil. And that just creates little conduits, little areas that those pesticides can get down in there and to just follow those roots down into the soil and get incorporated that way. Cover cropping is going to be an important one. And then there are several others. I think this is going to work here. Let me see if I can. Okay, well, it's not going to let me go. We'll take a look at some things if we've got some time and if people have some questions. I got to keep this going though. So here are those, if you guys didn't get them, I'll leave this up for just a second. All right, I'm going to advance here. And if we need to go back to it, just let us know. Happy to go back. Our all important civil rights slides. SDSU does not discriminate. And in Spanish to prove that we do not discriminate. Guys, and take down my information. If I don't know it, I can direct you to somebody who does, and I'm more than happy to help you out with anything that I can. The more I work in this position, the more people that I know, the more people that I can connect you with, and the more information that I know. So please reach out with any questions about this stuff. I'm happy to answer them. And so what I'd like to do is open it up to questions. Kira, what's the best way to do that? Are they going to be in the chat or?
Yep, participants can drop questions in the chat, or you guys can also submit them through Q&A as well.
All right. Oh, excellent. Thank you for tossing on those links for me. All right, so I'm not seeing any questions. What I would like to do real quick. First thing I'm going to show you guys is the Bulletins 2 Live. If you haven't been using this, you really ought to. Share the screen here. So this is the Bulletins 2 Live. This is updated as information is updated. So as we get more data, we can actually go in. And then one of the good things, they were doing this by county. EPA has re-envisioned this because they got a lot of flack. When you find a single species that could be endangered in a county, in a very specific portion of a county, why should somebody on the clear opposite side of the county be affected by that one animal they're never going to actually interact with? And so EPA has started to re-envision this. But I want you to take, I'm going to take a closer look here at Pierre or at South Dakota. All right. So each one of these pink areas is an area of restricted use, and I can just click on one. And so for this one, it's telling me that I can't use kaput. The reason I can't use kaput there, let's see if it tells me. Should tell me here. Okay, so it doesn't tell me why, but in this case, in this area, we know that there's black-footed ferret. Black-footed ferret feed on prairie dogs. Kaput, rosal, they're really extreme. They're toxic chemicals that don't discriminate between prairie dogs and black-footed ferret. And so if you get a black-footed ferret that gets into that stuff or potentially eats an animal that has been exposed to those things, they could potentially have it's lethal. It'll kill them. So we need to protect those species. So in this case, and in some cases, I know it tells us what exactly it's protecting. In this case, like I said, it's that black-footed ferret. Over here, we've got come on now, click. There we go. On the eastern part of the state, we've got some things that are going to be like Tavium or some herbicides. The reason that these things are there is likely for the Pauschik or the Dakota skipper. So a couple butterflies in these areas that are now registered as endangered. And it may not seem like a single butterfly is beneficial, or why should I have to worry about or care about a single animal? And let me put this in as simple terms as I possibly can. The more species that we have out there, the more resilient our habitat. That's extremely important. The more species, the more diverse, the more that habitat can put up to some abuse. If we only have 5 species out there that can only do 5 things, we're in a really bad position. Something happens that disrupts those 5 species, and we've lost everything. And it would be a very serious collapse, cascading collapse even. We're probably never going to find an environment that has just 5 species. It'd be really, really rare. But every species matters. And I need you guys to understand this. Again, we want that resilient habitat. And I know a lot of you guys already think about it anyway. I just want you to keep it in your mind. And so these are the pesticide use restriction or use limitation areas. Make sure you're checking these. This is something that you have to know before you make an application. So if you fall in any of these areas, Bulletin's live too, make sure you're checking at it. I'll take a quick look at the, yeah, there we go. So we should be looking at the mitigation menu. It's one of those QR codes, first QR code that I sent you. So you can scroll down. I would scroll right up past all of this stuff. It looks like I got it backwards, because those were the descriptions. Okay, so these are the descriptions. Here's what I wanted. I'll just type it in. We'll scroll down all this, get down to here. This is what we're wanting to look at. So you can actually visit this EPA website and you can look at where points are going to be given. And so that county list that I showed you, that picture, take a look at it, figure out what county you fall in, know what sort of relief points that you're going to get just from existing in this area. Field slope, that's not something that you really, I mean, you could control that at great cost, but field slope, hey, that's going to get you some points. And you can see over here, it gives you the amount of points that you would get from performing or having a situation similar to this. Sandy soils, there you go. And then we look at some things that we can do. Application reductions, reductions in the proportion of the field treated, incorporation. And so you can go through all these. And what I really like about this menu is that, say for this one, irrigation water management. So we can see over here it's saying use of soil moisture sensors, basically making sure you get the exact moisture content in your soil that you're looking for, not above, not below. And then we can actually look at what these things are talking about. And so it'll take us to the descriptions, and it gives you laid out. There are definitely some typos here, but it gives you laid out exactly what it's saying. And so you can follow that down, showing you some ideas or some possibilities for some soil sensors. And then, of course, like lower irrigation in applications that might not be as high up. So take a look at this stuff. It's again, we're talking years, more than a decade to get yourself into a place where you're compliant with all this stuff. And keep an eye on it, keep a finger on the pulse. Things are changing pretty dramatically. EPA is pretty headstrong about having this stuff work out and going forward with this. I think they're going to. There's a lot of changes that are going to be made. So just keep your eye, like I said, keep your finger on the pulse. I'm going to keep you guys updated as much as I can. But yeah, it looks like I've got at least a question here. So I An anonymous attendee asks, will spray records be the enforcement tool? I won't speak to the regulation. It's like I was saying earlier, the regulating this is going to be a nightmare. Extension is not the regulatory agency. The regulatory agency in South Dakota is the Department of Ag. And I can tell you from conversations with them, we're we're not entirely sure how we're going to enforce it. Enforcement's going to be pretty difficult. So I don't want you to think so much about the enforcement at this stage. We'll get there. What I want you to do is get yourself to a point of compliance. And when you're thinking about compliance, your records are always going to be your strongest source. So keep your records. If you had something installed that might retain that water, hey, make sure you keep those receipts, make sure you document exactly how many acres, where it was put, be able to show demonstrable proof that you installed those. And that way, when an inspector comes by, you do have those records and they'll look at it and say, okay, cool, well, you've got points there. Looks like you're compliant. So really, again, what I'd rather you focus on rather than how to get things through enforcement, what I'd really like you to do is focus on how to get yourselves compliant. I know that's a really good non-answer, but I can't speak to the regulation. We're not exactly sure.
You do
Any
have
other
a
questions?
yes, there's a question in the chat.
Nice.
Um, it is, how do we go about that without causing resistance related to application rate slash not using the full rate?
Sure. Yeah. So that's a good question. When it comes to resistant management, there are things that we can do. Applying the full rate, yes, that is one way to control it. And so if you're in an area that you're in, and this is where records come in, right? So you have records from the previous 5 years. If you just started, ask your neighbor, what things around here are really problems to deal with? They'll say kochia, right? Kochia is a real problem. How do you deal with kochia? And maybe they have an approach, or over the next 5 years, you gain experience. How are you controlling it? And so, how do you reduce that rate without causing resistance? Mix up your herbicides. Don't just use one class. Use group 3, use group 5, multiple classes of herbicides, and even use mixtures. And so look at our recommendations. We put out pest management guides. Look at our recommendations for how to control some of these things. In some cases, it's not going to be you just go out with one active ingredient and knock it back. Now, sometimes you need to use a mix. And so sometimes mixing up those herbicides will get you that control level at reduced rates. And we're talking about reduced rates per active ingredient. And so for mixes, I don't even think that they have a strategy for that. So at this point, mixes are going to be one of those that you could use and gain that control while reducing your rate across the board, if that makes sense.
Hey, Stephen,
Yeah,
I have kind of a follow-up question on that, and I think you hit the nail on the head with the mixtures and rotation, but something I've thought about as well, and I want to say, I think when it says reduction in the active ingredient, it's not recommending you use below labeled rates. So perhaps, something in the case of atrazine, max labeled rate is 2 quarts per acre, 64 fluid ounces. Now, here in South Dakota, we would never apply that because we'd have carryover to soybeans for years. If you grow small grains, that's going to be a problem. But excuse me, you know, we do spray about a pint, 16 fluid ounces. So I think would that count as, it would still be a labeled rate, but it would be that reduction in active ingredient.
yes. And so it is referring to that label rate. And so if you're in an area where you like Dr. Jones is saying, like if you were to apply full rate of atrazine, you could have negative carryover for the next few years. So if you're already using a lower rate, well, you're at the lower rate of that herbicide application. And so yes, that does get you some points. It's not saying that what you're doing right now reduce that. And it's definitely not saying go below the labeled rate. Remember, it's really important to understand that those labels really give you an outline on how this works. If you apply things at a lower than label rate, you're not going to get that effective control because the label tells you. So you could go as far as the lowest label rate, but remember, use your experience, use your farm records to sort of tell you what you can do at the lowest level in order to achieve the control that you're looking for.
Well, and I'm not going to interrupt you right now, but I just want to start to share the CCA
Oh, nice.
QR code just so I don't forget. Because if I don't turn it on now, I'm going to forget. And you can still answer questions and such as they come in.
And guys, don't feel the need, like if you don't want to ask a question here for whatever reason, feel free, shoot me an email. Gosh, I'll hopefully you got my contact information, and don't hesitate. You can call Dr. Jones to be able to give you some stuff. So please don't hesitate, reach out. I'm happy to help as much as I can.
The poll for today's crop hour has also been launched. So if everybody could just take a couple seconds to answer those two questions. I know the agronomy team uses this for future planning of events and for upcoming talks as well.
Well, I would just, Stephen, I'd like to just thank you again for giving that great presentation. It is confusing, but you did put it in a digestible manner. The one nice thing I like to see is, this isn't change your practice on top of its head next year. It's going to be a gradual process, and things are going to have to change, but I don't think it's going to be for the worse, honestly.
If I were to comment about this approach, I think change is always hard and it looks pretty rough. But when you detail it out, when you actually look into it, again, most of you guys are already there. You just need to recognize where those points come in, make records of those, and that way you can justify your use of that chemical. But I really think that this is a pretty decent strategy that sort of hits that line in between overregulation, under-regulation, and getting the mess suit out of them. I'm tired of my tax money going to pay litigation. So
No, I think it's, and the other thing I like to comment too, Stephen, I agree, the one or two species that are endangered, but if you look at the Dakota skipper up in the Aberdeen region, I hear a lot of just talk, I personally am a pheasant hunter, but you hear other people saying that those numbers of pheasants are going down, and it's not just a one size fits all thing, there's that chain reaction. If one thing starts to disappear, it has that cause and effect. And I think that's really important to think about going forward as well.
it's when you and I've been so impressed. I think that the broad impression is that farmers just don't care and that they're like, I just want to make sprays. And I'm sure that personality is out there, but most of the guys that I've worked with are I don't know that I'd go so far as to call them naturalists. That seems to be kind of a dirty word. But at the same time, gosh, they care about the environment. These are hunters, these are fishermen, and they get out and
Conservationists is the word they like.
it's yes, and they're very good at it. They're probably the most important conservationists across the board, and they really take good care and pay attention to it. And so I hope they see this and they're like, hey, this isn't so bad. And I hope I put it in a way that they recognize it's not nearly as bad as, at least some people are thinking it's going to be.
Well, if there's no more questions, again, thank you again, Stephen. Really appreciate you hopping on today and giving that presentation.
Thanks for having me.